problem. It's all about drawing the correct structure, right? So you've got a bow or a string on a bow, right? And we know that the length of this is 0.33 meters, right? And then when you bend the bow, or you bend the string with the bow, what you're trying to do is, and I didn't draw that equally, is it's going to, the string is going to be stretched that way, and what you're trying to solve is solve for D. Now, if we know this length is 0.33, this is halfway, 0.33 divided by 2, what did I come up with? 0.165. So that means this is 0.165. So if you know theta, bingo, you know the answer. So the key thing is what is theta, but how do you solve for theta? So what did I do? I said, so let's try and figure out from a tension perspective. Now they gave us the tension in the string, which was it? 65 newtons. And when you stretch it, it's going to be, well, let's break this down. This is the tension right here, right? This is the tension in the string. And so that means that the tension here is going to be T cos theta. But we've got it twice, right, on either side of the stretched string. And so if you think about it, the tension in this part is going to be 2 T cos theta. And that has to equal, at the point where it's going to bounce back, it has to equal the force of the static friction. And we know the force of the static friction is mu times the normal force. And we know mu, they gave it to us. What was it? Point something. It was 0.6. So it's equal to 0.6 times the normal force. And the normal force, they said, was 0.75 newtons. And so you take 0.6 times this is 0.8 times 0.75, and it came out to 0.6. That's what it was. So if you know this, now we have an equation where we can say 2 cos theta equals 0.6. Now you're going to solve for our t, and we know t is 65, so 2 times 65 cos theta equals 0.6. And at this point, you find theta. So find what theta is, and at this point, we now just have a triangle problem, right? We have a trigonometric problem where we have a triangle right here where we know this is 0.165 meters, and we know what our theta is, and you're trying to solve for this x or this distance, and that's how you do it.